Okay,
Let's
watch
see if we
the
can see
two
what
car.
caused this.
Oh, Meal got into Riggs.
It looked like Riggs had to maybe back out of the throttle a little bit because Kenny Wallace's car washed up as they come off.
So, for our kinematics equations, we have our givens, which is, so for V1, which is this initial speed, which is the top speed, we want to find that out. So we don't know what that is. V2 is 0 because when a car crashes, there is no movement at the end. Our T is 0.1 seconds because it takes 0.1 seconds for the crash to happen. And A is the acceleration, which is 686 meters per second squared. We have to put a negative in front of the 686 meters per second squared to show that it's slowing down. It is accelerating negatively. So this acceleration is found to be fatal. So now we have to find the kinematics equation that will give us our top speed, which is V1. So we want to find V1. So we plug in our numbers. We have negative 686 as our acceleration, 0 for our V2, minus V1, which is our unknown, over 0.1 seconds. So we're going to do a little algebra. We need to take off 0.1 seconds on both sides to get rid of the fraction. So we multiply it on both sides. That gives us negative 68.6 equals negative V1. We want to isolate V1, not negative V1. So we have to divide it by negative 1 on both sides. This gives us 68.6 as our V1, which is our top speed, meters per second. Then we have to convert to kilometers per hour. So we take 68.6 and divide it by 3.6. And that gives us V1 equals 246.996 kilometers per hour.
Oh, hey there! I was just listening to some classical music while doing some physics work. But enough of that. So, I was just looking at NASCAR car crashes, and at times, these speeds can be fatal. Here, we found the top speed to be 68.6 meters a second, which is a fatal speed for a car crash. If we look at our motion graph here, the car will be traveling at this speed for a time, and then it all changes in 0.1 seconds. That's the time it takes for the car crash to happen. The car slows down very quickly, and then all of a sudden it crashes. V2 is 0, the car is motionless. This sudden impact acceleration is fatal at this speed.
I realize that scene was rife with scientific inaccuracy.
Yes, I know men can't fly.
No, let's assume that they can. Lois Lane is falling, accelerating at an initial rate of 32 feet per second. Superman swoops down to save her by reaching out two arms of steel. Miss Lane, who is now traveling at approximately 120 miles an hour, hits them and is immediately sliced into 3 equal pieces.
Unless Superman matches her speed and decelerates.
In what space, sir? In what space? She's 2 feet above the ground.
Physics is used in real life a lot with safety technologies like the safe cars of the future that can stop accelerating at a certain speed. Also, kinematics is used for getting stats in NASCAR, like finding top speeds and acceleration rates for magazines and news articles. Kinematics is also used in real life for knowledge for drivers that are driving, just around town. Especially new drivers like us, like in driving school, we have to learn about braking distances, and that's all kinematics. Also, there's safe amounts of acceleration that can be learned using kinematics in NASCAR or in real life.
Kinematics is not only used with cars, it's also used with to find information about sports, animals, airplanes, and amusements. So for sports, we know records and stats. And for animals, we know the speeds, for example, speed of a cheetah and flight speed for birds. We use kinematics for rocket ships and how they can take off. That's how we have airplanes and rockets, is kinematics. And we also use it for amusement, like such as roller coasters. We need to use kinematics to build them.
So that's physics in real life.